Hello, my name is Juana Venegas. My major is engineering and what I'm going to is civil engineering. I'm your moderator for this session and quick reminder, there is a survey that we have to fill out and that survey will also serve for the raffle. It is my pleasure to introduce our presenter, Jim Milke. Yeah. And we will be for this session engineering for fire safety. So please welcome our presenter. Dr. Jim Milke is a professor and chair of the Department of Fire Protection Engineering at the University of Maryland. He received his Ph.D. in aerospace engineering, MS degree in mechanical engineering, and BS degree in fire protection engineering from the University of Maryland. In addition, he has a BS degree in physics from Yersinis College. Jim Milke has served as fire protection engineer for Fairfax County, Virginia, and as a research fire prevention engineer at NIST. Dr. Milke is a fellow and past president of FPE. He has received awards for teaching communications and service from the University of Maryland, and FPA, SFPE, Automatic Fire Alarm Association, and Siemens Building Tech Division. Please welcome our presenter.
Thank you very much for the introduction, and thank you very much to PG Community College to invite me to speak to you during your STEM week. So it's a pleasure to be part of the conversation here. So let's get to it. So the conversation I have is to talk about the use of the field of engineering, so science, technology, engineering, to address fire safety issues. So what is fire protection engineering? Well, in short, we say that fire protection engineering applies science and technology, and those four words could be used to talk about any engineering program. But for us in fire protection engineering, we're going to apply science and technology to provide and help develop safe innovations. Right? And we get a new innovation, or there's a new building. I see one going up just out the window here. And as we walk into that building, or we put a phone into our pocket, we assume that as we walk into the building, it's going to be fire safe, and we'll be able to walk out after a class. That our phone is not going to ignite in our pocket. That we'll be able to fly on an aircraft, and we won't have a fire on that aircraft. It will land safely. So we look at these kind of things that we can't take for granted. Somebody has to have addressed the fire safety aspect of any of those dimensions. So you see electric vehicle up in the top left. You see Grenfell Tower, a high-rise building where 84 people died back almost 6 years ago now, where the fire burned exterior cladding, where that exterior cladding, that exterior surface of that building was put there for energy conservation. So wonderful innovation, wonderful goal, but not the right materials, and the installation was somewhat flawed as well. Bottom left, aircraft fires that this is a UPS plane that happily landed, but was basically destroyed by a fire back now 17 years ago, as a result of not having good detection in the cargo compartment, good fire detection. And then finally, in the bottom right, in Delanco, New Jersey, that's near my hometown of Cherry Hill, New Jersey, that has a Dietz and Watson warehouse. So lunch meats and prepared meats and so on were stored in that warehouse. That's solar panels that are ignited on the roof of that building. And again, solar panels are a wonderful invention and clean energy and so on, but they're combustible and pose a significant hazard to firefighters once they ignite, in that they remain charged. You can't just turn a light switch off and remove the charge from a solar panel. So firefighters need to be very, very careful before going on the roof. In the contact with a solar panel could lead to electrocution. Want to say first of all about the fire protection engineering at Maryland, where again is my home department. We're the only accredited fire protection engineering program in the United States. So that our graduates get incredible job opportunities. I'm talking in March here that all of our May prospective grads have jobs. And I could have said that back in January as they came back for the spring semester. Some had them back early fall. So there are tremendous job opportunities in the Baltimore, Washington area here, but also across the country and even overseas. We're one of 3 fire protection engineering programs in the United States with a graduate degree program. And as graduate degrees usually involve research, that means we get some incredible research opportunities that get involved in addressing fire safety problems that the United States industry or government is faced with. So let's talk through some of these challenges and what are the fire safety implications and what are the fire safety concerns. So energy storage. Energy is routinely a challenge in that some describe fire as an uncontrolled release of energy. So if we have energy storage, there's some inherent hazards in almost any kind of energy storage, be it an electric vehicle, a battery. On the bottom left here, we've got a lithium ion battery that's gone critical. It's gotten overheated and now is in a runaway reaction where basically the interior of that battery is being spewed out in the fashion of a flare. And you can imagine if there was anything ignitable next to that battery, there'd be a much larger fire. This is that same solar panel fire that I talked about back previous slide, where it started somewhat small, but eventually involved the entire roof. Again, because firefighters were somewhat reluctant to go on the roof to attack that fire for fear of their own personal safety. And it basically, you could see what was left of the building, which is very little. Energy storage systems. So if you look at an array of solar panels in some fields that we see, these solar panel farms, I guess they're called. There's one in Howard County that I go by quite often of just solar panel after solar panel and acres that are occupied by this. That the energy from those solar panels have to be stored somewhere. So that involves now battery or sets of batteries, as the case may be. Here is one of those energy storage systems that is in a building. It's about the size of a shipping container. They had a fire that got started in there. From all the indications, it looked like things were pretty well under control. They had taken the necessary safety precautions in approaching that fire, letting some interior fire protection systems try and work. But things didn't go as planned. And now almost 4 years ago to the day, this eventually got to a runaway reaction where there was now an explosion. There's hydrogen gas that gets released in these as these batteries are off-gassing and decomposing. So you have a hydrogen explosion basically inside this small shipping container. And there were a couple of firefighters who were trying to make entry at that point. Looked like everything had settled down that they could do that. And they were significantly injured. There were a couple of them that were blown in the air 75 and 80 feet. Survived happily, but with some pretty significant injuries. So there's a lot of concern nationally for better precautions for these kind of facilities. There's a standards committee that just recently got formed that I'm serving on to try and address what do we do with these, because they're new development. They're huge in the way of, again, for solar panels and energy storage. But of course, we need to provide safe energy storage systems. In terms of our infrastructure issues, so I talked about the Grenfell Power Fire, for example, where the exterior cladding was combustible, and these fires happened all too often. There have been many of them, easily one a year over the last dozen years now, internationally, that are noteworthy and basically cause a virtual entire destruction of a building. You can see this one tower in Dubai here on the left, that experienced 2 fires, and there was that same issue of the exterior cladding that burned. burned in 2015. They replaced it, burned again in 2017. And the ironic part about this, that's I know that don't know that there's a lot of I don't anything that we could say in a lighthearted sort of way, but the really ironic piece about that particular building and that particular fire is that building was labeled the torch. That's what the architects called it. That's what the owner called it. And twice it has significant fires. The one in Milan is the most recent significant fire that I could find in a recent survey. So happily, I guess it's been a year since there was an entire building involved in fire because of the exterior cladding, but they happen all too frequently. There are tests that can be done to check the flammability material, and that's what a fire protection engineer or a fire scientist would do. These are a couple of our students. You can see on the right in our lab that's doing a combustibility test with materials. So these are things that can be tested, and it can be tested ahead of time before they're installed to check to make sure the proper materials are being used. Wildfires have been very much in the news for easily the last 10 years, and perhaps last 20 years in the country. I mean, we've had wildfires since the beginning of time, but they've been devastating and much more frequent in occurrence, especially out in the western part of the U.S. And also much more catastrophic for that matter. I will say, as we're here in Maryland and on the East Coast, we say, we don't have wildland fires. About 500 a year here in state. Now they don't get anywhere near as significant as the ones you see on TV or in the media, the California experiences, but we absolutely have them here in Maryland as well. So the research that we get involved in here, and this is a new area for fire protection engineers, I have to say, not a topic have dealt with historically. We usually get involved in fire safety of buildings and refineries and places like that, and not so much wildland applications or forest fires as they've been called. But the fire protection engineer can get involved and is involved based on a knowledge of can we understand how fires spread, and that's part of our training, part of our background is to understand fire spread, to be able to predict fire spread, so that as this fire is coming across this little grassy area here or forested area toward this community, for example, at some point there needs to be a decision, and maybe it's already happened in this particular case, but at some point somebody's got to decide when to evacuate that community, and that would be based on improved fire prediction methods, right? Same with where the incident commander directs the resources to address that fire. That becomes important in terms of where the firefighting forces are placed and where the equipment is placed, based on where that fire is going. The better attack it or get out of the way so that they don't lose equipment, they don't lose people. Part of the research that we do, and as part of our efforts, part of fire protection engineering in terms of community planning and that sort, is as I say, understanding how these fires spread. Right, and a piece of how they spread it's in somewhat we might guess that the flame just travels slowly across the surface like it might be traveling across a carpet, but that's only a piece of how they spread. With any fire, and that for any of you that have seen a bonfire or a campfire or any of that, there are lots of little embers that you can see in the right-hand photograph. Lots of little embers that are given off, and those embers float and can travel downwind some distance, still ignited, and then land on something, and they'll start a spot fire there that might be quarter mile, half mile away from that actual fire front. So understanding the brands and where they go and when they break off, where they go, how they land, do they ignite something when they land, is part of the research we're conducting at Maryland. And look to change those predictive tools accordingly. The bottom couple of photos you see on the left, those are little brands, burning brands that we create in our lab. The burning brands we create are made out of little wood dowels, so we don't go out into a forest and break little branches apart. We use dowels. The bottom right is an infrared diagram that shows temperature profile. So if that brand lands on a piece of wood deck, does it ignite that wood deck? And that depends how hot the local area around that wood deck or that cladding, vegetation next to the house, any of that might be, siding of the house, and any of those kind of things. So this, as much as this is maybe not an engineering innovation, the way I started the presentation, keep in mind that there are a lot of individuals that want to move to be in the wildland, be in a forested area. It's a country environment and it's wonderful and so on, but it has its set of risks, and that's where the homes in that area could be better constructed, better designed to not be prone to wildland fire ignitions. So light frame construction is or wood construction is an issue and has been for many years, where it becomes relevant these days and where fire protection engineers are looking very seriously at wood construction. Wood has the positive feature of being a very sustainable material. So in terms of sustainable construction and green construction, there's a preference for having buildings made of wood rather than steel, rather than concrete. It requires less resources to make a building out of wood than it does steel or concrete, especially when you think of life cycle costs. But wood comes with a bit of a problem in that it burns, right? And if it's light frame, if it's little 2x4s or smaller, we get into apartment building fires or condo fires like on the right here, where fire can spread very quickly, damage the entire structure. On the left here is a fire from 6 years ago almost. This was an April timeframe of this building just right across the street from campus. Coincidentally, so right on US 1 that consumed a building. It was almost ready to be opened, and this upper square was destroyed by the fire. The fire department was able to stop it before it got into this wing, but this whole part on the top that was that square section was lost in the fire. That fire is the largest fire in Prince George's County history. Damage wise, dollar wise, direct damage was significant. No one died in that fire, happily, but the damage levels were high, and it was very disruptive to the community. There was a senior citizens living center had to be evacuated. That was there. US 1 it goes up and down College Park. Maybe you've been to College Park, and it gets shut down that day. So that's a major thoroughfare. So that was shut down for the better part of the day. Campus closed for a part of the day. And as much as you'd say, if college closes, what's the so what? Well, there's lots that goes on and is productive for those that work in college campuses. We'd say that's a loss to the community, where we're shutting down, not just because of our educational programs, but all the research and all the things that go on at a university at a close. So wood's not necessarily the best material, but it has its possible positive advantages or positive characteristics, as I'll mention in a moment. So on the left is common masonry concrete type construction, and this is our performing arts center as it was being constructed. So any of you that have seen a show or a play or an event at the Clarice Center on campus, right near the football stadium, that's it going up. So clearly fire resistant construction, though not the most sustainable material. It takes a lot of energy to make the masonry or concrete units. There's wood again, and that's the light frame 2x4. That's maybe not the best, as we showed in a couple photos before. But here, this is a recent development. This is called mass timber. So now the the wood members are large. It used to be called heavy timber and mill construction back. So it's going to take a long time for a fire to burn to cause the columns and beams of that size to collapse. Right? Much more resilient. to fire. And there's a tremendous amount of interest internationally in mass timber construction because it's sustainable. It has improved fire characteristics in some respects. Again, with a proper fire protection in there, that's a completely acceptable situation to deal with. So the US is a little bit trailing the trend for mass timber. Internationally, it's very, very popular, especially in Europe and Australia. But in the US, it's coming along. There's I think the tallest building I'm aware of, it's a 17-story building with mass timber was done in Norway, back just a couple of years ago. One area that we get involved in is fire protection engineers, and this, I don't know if this is so much of an innovation per se, but this is a bit of the times that we're in, right? With pyroterrorism getting used, or where fire is used as a weapon, right? And there are a series of these incidents that have occurred in recent times, and they continue to occur. With the whole idea, can we make buildings more robust and consider the possibility of pyroterrorism? The building on the right, in New York in 1990, that's the Happy Land Social Club fire. This was basically a renovated building or a repurposed building to have a club in the second floor. This was basically a residential area. So had one exit to it. So they're already, for fire protection, here's some flags. You put a building with one exit, you make what was a resident say, hey, let's put a club up there with lots of people. So there could have been some things to make that facility more robust. The problem was there was someone that attended the club that night and had a bit of a fight with somebody else in the club. So they came back and started a fire there in the hall, in that stair. That that people couldn't get out, and there were many fatalities. Welcome, glad you could all join. In the middle, hotel in Islamabad was a bombing sort of accident. Fire developed to cause a lot of damage, and of course, World Trade Center. And there was a lot of question after 9/11 with that went on, and with the plane attacks. And perhaps the original intent was the plane attacks would bring the building down. Didn't happen. Building withstood the plane attacks, right? The plane impact itself. And they had done some design work to see if the building could withstand that. But it was a fire that brought those buildings down that day, right? Because of a structure that was weakened as a result of damage caused by the planes. They were not enough to bring the building down immediately, but the fires that resulted were enough to bring those two buildings down, and a building 7 that was crossed. I was part of a federal team that studied 9/11, studied these two buildings and why they did what they did that day with part of the preliminary investigation. And a big part of our charge and why Congress wanted the U.S. Fire Administration or DHS, I should say, to study this was, given that, do we need to change the way high-rise buildings are designed in some fashion to be able to deal with something like that? And there have been some changes since 9/11 in very tall high-rise buildings to improve the robustness of them. Certainly when the Freedom Tower was designed, that occupied that general area of Lower Manhattan, they took into consideration the possibility of pyroterrorism when they designed the next structure. Some other areas that are really exciting areas, and you see in so many fields of engineering, and fire protection engineering is a piece of that the smart buildings are coming about. There are some of these that exist already, at least in some fashion, where a building is with all the sensors that we put in buildings, and be it light sensors or fire sensors or thermostats or humidity or carbon dioxide or whatever kind of sensors in there, we engineers can learn a tremendous amount about how that building can function in terms of energy conservation and also in terms of fire safety. And one of the things that we did some research that I think has a tremendous potential has a tremendous potential, is providing improved situational awareness to firefighters. I entered this field many years ago being a volunteer firefighter. Now, that's not required to be a fire protection engineer, but that's how I came to know about fire protection engineering, because I was a volunteer firefighter. I was pursuing a degree in physics at the time and wasn't sure what I was going to do with a physics degree. And got this interest in fire safety and said, I can apply my physics talents to fire safety. So but we started on that. Being a firefighter, we haven't changed largely the way firefighters go into buildings today than we did when I was a young firefighter back 40 some years ago now. The firefighter goes into a building, they know there's a fire somewhere in a building. You might know where that detector is operated, what room it operated. But otherwise, you have no clue what you're walking into. You have no idea how big that fire is going to be. You have no idea what's burning. So as a result, what has to happen? You have to carry in all this extra equipment that maybe you don't need much of anything except a little portable extinguisher. Can we provide better information to firefighters? Is the question. And we did a feasibility study. We had it was a hangar was the application, the aircraft hangar was the application we looked at, but it could have been any open building in principle, and there are many more building designs we could do. We wanted to see, could we use sensor data? So there are sensors every 8 feet or so of this building. So really concentrated, much more concentrated than you'd find in a normal building. But let's get a lot of sensors in there and let's see what we can make out of that. And looked at temperature sensors and a smoke sensor, a smoke detector of sorts, right? And let's look to see with those two measurements alone, can we answer where's the fire in that space? How big is that fire and what's burning? And in an aircraft hangar application in particular, what's burning becomes very, very important. It's important in any building, but especially in an aircraft hangar, because if it's jet fuel that's burning, the firefighter not particularly going to want to use water. Okay? If it's anything else that's burning in there, they're going to use water. Okay? So what's burning becomes really important again in terms of what stuff I have to drag into that hangar to try and attack that fire. We started this was a graduate student who worked with us, and I'm remiss in not having her name on either these slides. Allison Davis was the graduate who worked on this, graduate student who worked on us. She was a master's student, had our BS degree already from us, and ran simulations. We had simulations. We couldn't go in. Nobody let us to run a bunch of fires in an aircraft hangar as much as that would have been really interesting. But so we did a lot of numerical simulations, computer simulations of fires, and seeing how our simulated sensors would respond. And basically her idea is, can we identify, first of all, where that fire is within a 5-meter radius? Right? Had several different types of fuels, from Douglas fir, that's a wood, to propane, to paper, to JP8, that's a jet fuel comparable to diesel fuel, basically. Right? Had all these different fuels here. Stars were the actual fires. They only see 4 symbols here. That's because symbols are on top of symbols, right? But the model was able to predict in 80% of the cases the correct location of where that fire was within a 5-meter radius, right? And as I told her when we started the project, if we can get to 50%, we ought to call that a win. We were 80%. Oh my goodness, right? So she overachieved on the first one. That was the easiest one. So she told me. We looked at fuel composition, and we had 6 different fuels altogether. Here's the you make these little matrices to compare predictions versus actual, called confusion matrices as they are, or confusion tables. And you want to be along the diagonal to be correct. So here, there's the true fuel let's go here first, JP8. And how many predicted JPAs did we get? It was 87% she got right. And again, I was hoping 50. Let's get to 50, 87%. And for everything else, the papers and so on, 91%. Oh my goodness. Right? It was incredible. This was the aha moment when she showed this to me. So this is a simulation. Let's stop. Whoops. Nuts. I wanted to stop that. See if I can try again. Yeah, I'm not going to be able to stop it. You start to see colors, right? You see various colors that are forming here, and that'll get to the end, and it should hold for me. But you see the greens are in one spot, and that's one fuel. The green's propane. There we go. At the end. There's the blue that's Douglas fir, and purple was the JP8. So that each fuel has its own band that it's in as a result of only temperature and smoke. Only temperature and smoke. We were thinking we would want to use carbon monoxide, carbon dioxide sensors too, and maybe some other sensors as well, gas sensors, where we could do even better. But at 87%, that's a huge thing right there. 91% for jet fuel. And that was the key thing, remember, okay? Is it jet fuel or is it anything else? That's what the Air Force or airport firefighter is going to want to know in terms of what can I use as a fire extinguishing agent. And then had fire size, just in the interest of time, I'll include fire size. So fire size was another that it was in the 85% area and getting the fire size right. Fire size in terms of what was the heat output of that fire, and we measure heat output in terms of kilowatts in fires. Here's some current research that we're doing. This is the Kim Engineering Building. I don't know if any of you have been to College Park. This usually gets referred to as the main engineering building. It's where the dean's office is. So in this building has a 3-story atrium, and all the way at the top, and they're dots at best on what I can see here. There are sprinklers and there are smoke detectors. Periodically, somebody's got to inspect that sprinkler and got to inspect that smoke detector, make sure it's still working. Right? As with any engineered system or engineered product, you got to check it every once in a while, make sure it's still working. So how do you check to see if a sprinkler is in good shape or a smoke detector is in good shape and then physically damaged or corroded or whatever when it's 30 some feet in the air? Well, you have to get a lift, you have to get scaffolding. That's a huge amount of time to do that. And there's always a hazard or a danger of somebody getting hurt when they put somebody up in the air 20 some feet. So for all those reasons, we were approached by an industry contact. We have one of our corporate partners, Johnson Controls, that said, could you send a drone up there to do that same thing instead of sending a person up 20 some feet in the air? Can you send a drone up instead? Anybody have drones at home? Play with drones? Few of you, right? Could you do that, do you think? Could you send a drone up to do a lap? Sorry?
Depends.
Depends on what?
Well, AC, I don't want the drone to be blown all over. Over. Not to mention, I don't want to hit the sprinkler.
Right. That becomes a problem. All right. So short story. So we said, let's try it. All right. So I've got 2 sophomores working with me. Make sure you heard that right. 2 sophomores working with me, not graduate students, not Ph.D. students, right? I have 2 sophomores working with me where we're doing a proof of concept sort of thing. Can we do this? Right? Can we do this? Can we take a lap around the sprinkler? And we don't want to hit it. You're right, because you hit it, you're going to get water all over the place, and that's not going to be good. Can we take a lap around a smoke detector in the same sort of way and look for physical damage? With a smoke detector, they send out an IR signal. So to say it's functioning right. So could our drone pick up an IR signal? Yeah. Right. I mean, there's nothing that's impossible here that I'm talking about. It has to change, technology. It's simply using this technology for fire protection purposes. And one that's perhaps a little mundane in inspections, but something that's hugely needed. Because otherwise, it's likely that sprinkler, that smoke detector is just flat not going to get maintained. It's too much of a problem to deal with. So huge. And what we would love to do, so we're just doing feasibility this semester. Can this be done? We've got a licensed drone operator we found, so we can fly the plane or the drone inside. So we've got somebody that has some capabilities to fly a drone. So hopefully we don't hit lots of stuff. The other, where we would like to think that we could go with this, anybody have a Roomba at home? right? So can you, right, here's the vision. Can you, I put a drone down here, start it up and say, go. Go find the smoke detectors in the building, go find the sprinklers in the building, go. Right? And what would it take to do that? So you maybe put a little chip or a little QR code on each one that would allow the drone to find it, right? And then do a little inspection around that device, and to greatly simplify inspections and maintenance and improve the reliability of systems overall, right? Because you're going to find out if something's not functioning right a lot sooner than if you don't do any inspections. So this is up close. I walked up to a second floor balcony, going through that place to take that photo where there's a smoke detector and a sprinkler. And you know, we could have a drone. We could have the licensed operator with VR goggles that can all be recorded, so it could be sent to an inspector to look at afterwards. I wouldn't even have to have the inspector be right there. I have a licensed drone operator do this kind of thing inside a building. So we've got several buildings on campus that have been made available to us. The campus fire marshal was excited that, wow, yeah, this is great. Let's give it a go in terms of this. So we've got several buildings that we think we can use for this feasibility study this particular semester, and maybe they continue on beyond. Would be my hope as they become juniors, or maybe other sophomores come in to help. Maybe we get some transfer students from community college to help. This is also a bit of a vision, right? I talked about situational awareness for the firefighter. Firefighters are going to go into a smoky environment. They're going to have breathing gear on, so they'll have a headpiece on, as perhaps you've seen in videos or movies or wherever. And the question is, could you put a display in their screen to tell them what's going on? Oh, well, is that even possible? Can we even do a heads-up display in a screen? And the answer, yeah. We've been doing that for military pilots for years. And that's the diagram you see in the upper left. Right? So absolutely possible. I've had a couple cars recently, maybe you do or parents do, that have a heads-up display in the windshield, that I can see what my speed is, and will have my directions if I've got my GPS activated. You can tell me what radio station I'm listening to. So this is not new technology to think of a heads-up display. Can we do that for a firefighter? Technically possible. Where we can tell that firefighter things of, all right, so how hot is it in the room? How much visibility is there? Although they'll be able to see how much visibility there is once they're there. But to be able to know how hot it is, a room temp is what I have. Can we give them some vitals of themselves? So what's their pulse rate? What's their body temperature? What's their heart rate? These kind of things that become important in terms of the safety of the firefighter. Can we tell them that they'll have an air tank on their back? Can we tell them it'd be monitoring continuously how much air is left in that tank, in terms of telling them a couple minutes before they got to get out, they need to start making their way out when it gets down to just a few minutes, as opposed to waiting for the bell to go off because there's only about a minute left. Right? What's the temperature of their protective gear, PPE, at outside surface? And then again, a warning that maybe they better get out of there. It's getting too hot for the gear that they have. And maybe, and also I'm going to show here perhaps a floor plan, so they can see where they are in the building. It's easy to get disoriented in smoke. So can we give them that information too? So there's a whole bunch of different pieces of information we can provide that firefighter with personally, let alone send that out to an incident commander, to the fire chief at the scene, to say, oh, Joe Lynch, look at what he's dealing with here. We got to go get him. Or we've got to go get her, as the case may be, before they collapse and become a problem. Right? Just in a couple minutes closing here, and we've got plenty of time for questions, I think, so that's good. So just a little bit about the discipline. Again, fire protection engineering at Maryland. So your in-state school, right, has the only fire protection engineering program in the country. So you've got an incredible resource here. Right? And as I started when many of you weren't here in the room, all of our prospective May grads have jobs at this point. And I could have said that if I came here in January. Right? They all have jobs. As department chair, I get to hear from our students and they have problems. Well, yeah, what's your problem? I have multiple job offers. I don't know how to decide. Right? And I tell them, well, understand, that's not what we call a problem, first of all, right? And I'm happy to be a sympathetic here and see if I can help them work through a decision. Can't make a decision for them. But otherwise, so who hires all these people? Where are all these jobs? Well, there are a lot of them that are consulting engineering companies. I have those on the right hand of the slide. Many of these names you may not know. They're fire protection specific. Although Bechtel is here, so Bechtel's a big engineering company, a big name engineering company, would probably be one you would have heard of if you know engineering consulting companies. The rest are all fire protection companies or fire protection companies principally. Virtually all of them with offices here in Maryland. So if you want to stay in state, there are opportunities there. If you want to go elsewhere, that opportunity exists. This company Kaufman, you might get an opportunity to have to work in Honolulu if you go to work for them, among other places. They have an office here in Fulton, Maryland too. But if you want to go to Honolulu, that's them. Companies in the upper left, so corporations are there, and you could see. Actually, I should have put two from last year. Two of our graduates. One went to Tesla. One went to Ford with electric vehicle concerns. And otherwise, you can see an assortment of them there. Your eyes probably have gone to look at Walt Disney. Yeah, Disney. I mean, Mickey needs fire safety too, right? You want the rides and so on. You want the experience to be fire safe for people, whether it's a ride or a hotel or anywhere in the resort. So we've got graduates both at Disney World and Disneyland. Several at Boeing out in Seattle. So many jobs. Government agencies on the bottom portion, that's the only part I didn't mention. I mean, virtually any government agency you can name, you look at the alphabet soup of government agencies, and they all have fire protection engineers doing something, including the CIA. They can't tell me what they do, but they're there. I think they have something to do with fire safety of the CIA facilities. So a couple things, and this is dated now for the one. For more information, so here's my contact info, email address there, and I appreciate that putting that up there. Some of you might write that down and contact me. I've got cards here if you like old style instead. So that's here, and I hand these things out with